Alright, everyone, here are some more examples. The sum and difference rules. If you don't remember the sum and difference rules, they are right below me, right down here. So, there you go. If you don't remember them, you can always look them up, or you can look back to your notes or watch a previous video. So, the sum and difference rules, it's kind of the same thing for both of them, and all you really have to do is find the derivative of each part, right? So we can just say f prime of x is going to equal x cubed is going to be the same as using the chain rule, 3x squared, sorry, the power rule from before. The power rule, my fault. There we go. Okay, so we have 3x squared, and then it's just going to be x to the first is going to be that one goes here, and it's going to the x's cancel out, so it's going to just be minus 4. And the constant rule, the derivative of 5 is just going to be 0. No need to write it in, so f prime of x equals this whole thing right there. You see it? Great. Okay, so let's now try the next one. G of x equals this whole thing. So we can say that g prime of x is going to equal, that's a negative, so the 4 goes in front, so I'm going to have 4x to the third over 2, make sure it's negative, plus 3 times 3x squared minus 2. Right? So then all we have to do is clean this up just a little bit. 4 times divided by 2 is going to be 2 with the negative in front, so it should equal negative 2x cubed. 3 times 3 is 9x squared minus 2. And if we look at this, all these should have gone down 1 power. So I went from 4 to 3, 3 to 2, 1 to 0. So that just is a good way to check to make sure that you're not missing something or you didn't write in the wrong exponent. Okay, so now let's go to sine and cosine. If it's 2 sine x, this is going to be kind of like the constant multiple rule and a sine rule all at the same time. So we can say y prime is going to equal that 2 stays in front. And what is the derivative of sine? What? I can't hear you. What? Speak up. Speak up. That's weird. You're talking to some sort of internet-capable device. The people around you are probably looking at you like you're pretty weird. Yes, you're right, though. It is 2 cosine x. There you go. So 2 cosine x for that one. Now let's do this one right here. It's almost the same. We can say y prime this time is going to equal 1/2 cosine x because it's 1/2 first. Divide by 2 is same as multiply by 1/2. So we can say this one is 1/2 cosine x. Okay, and the last one we can say y prime is going to equal, what is the derivative of just x? Well, it's just 1. What's the derivative of cosine? That is negative sine x. So there you go. That is your answer. Good. Now, let's do just a few more. Let's do one with finding velocity. We gave you the velocity equation last 2 videos ago, right, with the beginning of all this stuff. So what we're going to do is at time 0, a diver jumps from a diving board that is 32 feet above the water. The position is given by s of t equals negative 16t squared plus 16t plus 32, where s is measured in feet and t is measured in seconds. When does the diver hit the water, and what is the diver's velocity at impact? This one, no calculus required. B, we need calc. Okay, so the first one we're going to do is, when does the diver hit the water? Well, that's when the distance is 0, their height is 0, so we're going to say that's when it's, for part A, negative 16t squared plus 16t plus 32 equals 0. So now you know that you can solve this doing lots of other things, right? First, what I would do is I'm going to factor out a 16. And you know what? I'm going to factor out a negative 16 because I don't like that first one being negative. So I'm going to say negative 16, factor it out. I get t squared plus negative t plus negative 2 equals 0. Now, I should be able to factor this. Are there numbers that multiply to negative 2 but add 2, positive 1? Let me see. Is it negative 2 and positive 1? Yes, it is. So we have negative 16, t minus 2, t plus 1 equals 0. So then we're going to say that t is either going to equal 2 or negative 1. So either at 2 seconds or negative 1 seconds is when the diver hits the water. Well, we kind of have a problem because negative 1 would be impossible. So we know that t equals 2. So we know that that is how long it's going to take. So now what we're going to do is, what is the diver's velocity at impact? When they hit the water, what is their velocity? So what we're going to do is, if we find the slope of our original function, that's going to tell us, or if we find the the if we differentiate this function, then we're going to be able to find what the equation is for finding the slope at any given time, and then we can plug in this 2. Okay, so we're going to take that s prime of t is going to equal, and I've got 2 going to go to the front, so 2 times negative 16 should be negative 32t plus the differential equation differentiating t squared, or just t, is going to be plus 16, and the 32 is going to cancel out. There's going to be nothing, so I really don't have to do anything. So that's my s prime of t. So now we just take that 2 and we're going to plug it in for t, and we can figure out how fast that diver is going when they impact the water. So that's going to be s prime of 2 equals negative 32 times 2 plus 16. So 32 times 2 is going to equal negative 64 plus 16. And then if we add those together, 64 minus 16 is going to be 58. 48 equals negative 48. And that's going to be feet per second. Right? Negative 48. Oh, there you go. Sorry. Negative 48 because it is going to be going down. The diver falls down, so the velocity is going down, not up. That'd be kind of weird if the diver was going up to the water. If we had pools on the ceiling, that'd be strange. So that is their speed in feet per second. There you go. Thank you very much. Have a good one.